morning from IIT Kanpur. You are here for yet another new session of the course titled Artificial Intelligence in Industrial Management Engineering. And I am Professor Deepa Philip. I am from IIT Kanpur. This course is part of the NPTEL MOOCs offering from IIT Kanpur. And along with me, Dr. Prabal Pratap Singh is also co-teaching this course. And we have been looking into the previous lecture about expert systems and broad architecture of what an expert system is about. And we also saw that the expert system, the three key components are user interface, inference engine and knowledge base. And if you look into the yesterday's slide, this is what we had discussed about how the broad architecture, the initial architecture of expert system turned out to be. So continuing in this, so first thing, let's take the knowledge base. What is it? And so I said earlier, it contains necessary domain knowledge. Necessary domain knowledge. Okay. And for A, understanding, B, formulating, and C, solving problems. Okay. So that is the necessary domain knowledge which should help in understanding, formulating and solving the problems. There are two basic elements, basic KB elements, knowledge base elements. Okay. Which are those two? Okay. So the first one, A, facts. Okay. So what are those? So the factual knowledge is that knowledge of the domain that is widely shared typically in textbooks and journals. Yeah, so that means mostly authentic, commonly agreed upon. Commonly agreed upon by those who are knowledgeable in the field. Okay. So it's a factual knowledge is the knowledge of the domain. Okay. Which domain? Whichever you are working on. Okay. Whichever the domain you are working on. So that knowledge which is widely shared, okay, shared broadly across, typically in textbooks and journals or typically in publications. This peer reviewed, people have reviewed it, verified it, authenticated it, and people commonly agreed by those who are knowledgeable in the field. So that is the facts. Okay. Now next one is B, heuristics. Okay. Heuristics. So heuristic knowledge is less strictly defined, relies more on empirical data, more of judgmental knowledge of performance. Judgmental knowledge of performance. Okay. So what is that? It's less strictly defined. Unlike the facts, it relies more on the empirical data, on your experience and judgmental knowledge of performance. So like people looking at the conditions and say that okay, it may rain today without looking into the data, but based on hunches and other things. That's an example of heuristic. Okay. So, I asked you guys earlier in the previous lectures to look into the MYCIN thing, okay, and some people had asked many questions. So, I thought I will give a quick summary of MYCIN from 1970 to 1980, that was the life of that expert system. So, main features, main aspects, okay, related to this. First one is 50 to 500 rules acquired from experts by interviewing. So, there were a lot of interviewing going on, and from the interviewing these 50 to 500 rules were created. Okay. So, example rule, if you read through the documentation you will come across this rule there. So, I am quoting that example rule. If the strain of the organism is gram negative and morphology is rod and aerobicity is aerobic, then strongly suggestive, okay, 0.8, that the organism is enterosebaceous, okay. So, it is a mouthful. So, they have a rules, example rule like this. So, the other part is rules matched well with the knowledge in the domain, So, like the reason is because medical papers often present few rules. Then the logic here is rule is equal to a nugget of independent knowledge. So, the critical aspect is it had about 50 to 500 rules. It was acquired from experts by interviewing. Then an example of the rule is the strain of the organism is gram neg and the morphology is rod and aerobicity is aerobic. So, the three conditions, right, gram neg, morphology and aerobicity. Then strongly suggestive, they given a number to that the organism is enterosebacterious, right, and as well as the rules matched well with the knowledge in the domain, because many of the times medical papers also present you few rules, and in this case the rule is like a nugget of an independent knowledge. Continuing, the thing is facts or not facts. So, let us take this part. Okay. So, first thing, morphology is rod. Okay. This is the condition. Okay. It requires evaluation through microscope, So, you have to use a microscope to figure out whether they, now the questions is, one question is a bean shape a rod? Okay. Another question is an S shape a rod? Okay. So, these kind of things are also so the person who is looking through the Microsoft will tell you whether it is rod or not. Okay. So, morphology is rod is assigned a confidence. assigned with a confidence. So, instead of saying the rod or something, the person can assign a confidence. Okay. And the other thing is, so hence, if so, all facts have assigned confidences ranging from 0 to 1. So, like, because somebody have to look through the microscope and say whether morphology is rod. Now, there are conditions that say something might look like a bean. Okay. So, whether the bean is a rod or S is a rod shape. So, hence it was assigned with a confidence. So, hence for MYCIN, all facts were assigned a confidence from 0 to 1. Okay. So, what is it in a nutshell? Okay. So, in a nutshell, it begins with a few facts, okay, about the patient. Okay. Why do you need these few facts? These few facts required by physicians. Okay. The height, weight, all those kind of things. The physicians need it, the system does not need it. Okay. Then, if you read it, you will understand that backward chaining from, or backward chaining is fine, chaining from each possible goal or disease. Okay. So, the backward chaining was used in this case. Then preconditions either match facts or set up new subgoals. Okay. And subgoals may involve tests, may need some tests, aerobic, morphology, okay, that aspects. Then find all proofs and weigh them. Because we saw that they had a confidence varying from 0 to rule all facts, right. Then explain decisions and combine evidences. Combine evidences, that is the next step. Then let us say outcomes, okay, worked better than an average physician. Yes, so the system worked better than an average physician, right, but never used in practice. Okay. In practice, it never got used, but methodology was used. Okay. So, people learned the methodology and that methodology became popular. So, this is what the MYCIN in a nutshell. So, I request you guys to read through this. Now, let us talk about we have seen some examples of backward chaining, but we did not talk much about the forward chaining. So, let us talk about the forward chaining interpreter today. So, how it works? The first question is how it works. So, first is repeat, it is a loop, apply all the rules to the current facts. Okay. Then each rule firing may add new facts. Okay. So, repeat, then until no new facts are added. Facts are added. Okay. Repeat until no new facts are added. That is the way this is thought through. Then this is comprehensible, which means also understandable. Then other aspect is, so the algorithm side is this much. Now, we also says trace of rule applications that lead to the conclusion is an explanation. So, if you trace the rule application, okay, and that results into a conclusion, that resulted in the conclusion, then that gives you the explanation, which means answers why. The why question gets answered by the explanation. So, let us do a simple example, okay, because it may makes you life easy. So, let us talk about few facts. Okay. This is just a contrived example. Fact 1, F1, okay, mid-clo gives milk. Okay. F2, fact 2, mid-clo eats meat. Fact 3, F3, mid-clo has hoofs. Okay. So, mid-clo gives milk, mid-clo eats meat, but it has hoofs. Okay. Now, these are facts. Now, let us talk about the rules. Rules. Okay. Rule 1, R1, if X gives milk, then it is a mammal. Okay. So, if an animal gives milk, it in the form of mammal. Rule 2, R2, if X is a mammal and eats meat, then carnivore. R3, if X is a carnivore and has hoofs. Hoof means like the hoof of cow, horse, etc. Then Myconicia. Okay. Myconicia. Okay. It's an extinct animal. So, how is this will work? The logic basically says apply all the rules to the current facts. Okay. So, all the rules. So, first thing is if you apply R1 working. Okay. So, R1 apply all rules. If you apply R1, okay, so apply all the rules to the current facts. Okay. So, R1 all the rules we have to apply. So, R1 is if X gives milk, then it is a mammal. So, if mid-clo gives milk, obviously yes, it says mid-clo is a mammal. Okay. Then R2, if X is a mammal and eats meat. Okay. So, now we take that to all. So, we apply the rule to all facts. So, for if you take R1 to this one, it is not applicable. R2 to fact 3, it is not applicable. Then we take R2 we apply to F1. This comes from F1. R2 then says if X is a mammal and eats milk, then carnivore. Then we says that mid-clo is a carnivore. This comes from F2, and then if you apply R2 to F3, mid-clo has hooves. It has nothing says about it, so that would not return any conclusion. Then we take R3 and you apply it to F1, nothing works out. F2 nothing works out. The F3 it says it will conclude that mid-claw is Mesonesia. Okay. This comes from F3. So, the conclusion, by going through each progressive application of the rule, we can easily see that mid-claw is Mesonesia. So, if we do this with backward chaining, just to compare. Okay. So, how do we do that? We will start with the goal. Okay. You are starting with the goal. So, G1 is mid-claw a Mesonesia. Okay. So, that is the goal that we need to start from here. Now, we say that G1, if you look into this one, so if you can see that the G1 matches some of the conclusions of R3. You see the R1 is if X gives milks, then it is mammal. If X is a mammal, it means carnivore. So, we know those three rules. So, forwarding that, we can say that G1 matches the conclusion of R3. So, then sets up premises as sub goals. Now, from here we create sub goals. Okay. Now, G2 mid-claw is carnivore. Goal 3 mid-claw has hoofs. Okay. Now, we can see that G3 matches fact F3. So, true. Okay. So, what is F3? F3 is mid-claw has hoofs. Okay. So, you can see that there are three facts: mid-claw eats milk, mid-claw eats meat, and mid-claw has hoofs. Okay. And then G2 matches conclusion of R2. Okay. So, true, etc. Okay. So, you can see that we start with the goal. In the forward chaining, we started from the rules and we moved forward, whereas and applied to each facts. In a backward chaining, we started with the goal and we moved backwards and find the rules which actually matches. Okay. So, what are the advantages and disadvantages of this? So, the simplest thing is forward chaining. Okay. Number 1, allows us to conclude anything. That is the first thing to do, and forward chaining is expensive. Now, backward chaining. Okay. Requires known goals. You need to start with the hypothesis or the belief system, right? Then premises of backward chaining directs which facts or tests are needed. Okay. Now, the other one is, so also the rule traces provide the explanation. Okay. So, that is the other aspect of it, right. So, hopefully this makes sense. Okay. Now, let us just briefly looking into this, took an example of forward chaining and we saw that all the rules. So, what the logic is that take all the rules and apply sequentially to each one of those facts and then from there conclude, whereas in backward chaining set up a goal and work backward. So, while forward chaining is more computationally expensive, the backward chaining requires rules and rule traces actually helps you to provide the explanation. Right. Now, what we will do is we will get into what do you call us, we will start with the simple confidence calculus today. We will take this slide and then we will stop the lecture here, and then we will do the math based versions of this one next. So, simple confidence calculus, just to demonstrate something, okay, this will yield an intuitive degree of belief in the system. Conclusion. This will yield an intuitive degree of belief in the system conclusions. Okay. That is the first one. Now, the thing is, to each fact assign a confidence. We saw this in MYCIN. It's in a confidence or degree of belief, which is a number between 0 and 1. Then we say to each rule, okay, assign a rule confidence. Okay. So, for each fact we assign a confidence, a degree of belief, okay, which is a number between 0 or 1, and for each rule we assign a rule confidence, okay, also a number between 0 and 1. Okay. So, the confidence calculus, the premises is for each fact we assign a confidence degree of belief or confidence 0 and between 0 and 1. For each rule we assign a rule confidence, which is also a number between 0 and 1. Okay. By using this, then how do we do the rest of the stuff? We will see in the next class. So, thank you for your patient hearing, and I would really request you guys to read much more on the MYCIN and get understanding about the expert system. Thank you, and we will see you soon with the next lecture.